Have you ever paused to consider that the very words you're using right now aren't just vehicles for your thoughts, but might actually be quietly, profoundly changing your brain and even how you experience the world around you?
That's a fantastic question to kick us off because what we're diving into today is exactly that. We're looking at how language, well, it's far from being just an abstract system in our heads. It's actually a dynamic process, what we sometimes call an emergent phenomena.
The emergent phenomenon, what does that mean exactly?
It just means it arises from this complex, interconnected interplay between our brain, our body, and our environment. Language is this incredibly powerful tool, as our course materials really highlight, that has fundamentally transformed the human mind.
Okay, so let's really unpack this. It sounds huge.
Yeah.
If language is such a game changer, what's the first big insight into how this amazing tool came to be? Because it sounds like it wasn't just, a simple switch flicked in our brains.
Yeah, exactly. And that's where the story gets really interesting. One compelling view put forward by cognitive scientists like Elizabeth Bates is that language is like a new machine built out of old parts.
Old parts.
Yeah, think of it like this. Evolution didn't suddenly create entirely brand new genes or brain structures just for language. Instead, it was more like a master tinkerer, leveraging and repurposing existing biological tools to create something novel.
So no single language gene then? Or like a language organ that just magically appeared. That feels really counterintuitive, doesn't it, when you think about how unique human language seems?
Precisely. I mean, take the FOXP2 gene, for example. For a while, it got a lot of hype, sensationalized as the language gene. That was after studies on a specific family, often called the K family, who had the severe speech and language disorder linked to a mutation in this gene.
Right, I think I remember hearing about that.
But here's the crucial bit. FOXP2 is actually evolutionarily conserved, meaning versions of it are shared across loads of different species: chimps, mice, birds, even alligators.
Alligators.
Seriously?
Seriously. So it plays a role in brain development and motor control more generally, not just language specifically. Our brains didn't invent something entirely new from scratch. Instead, they adapted and repurposed existing domain general skills.
Okay, what are domain general skills?
They're just broad abilities. We have things like problem solving, pattern recognition, learning, understanding someone else's perspective. These skills were then kind of co-opted and fine-tuned for the really complex demands of communication. So as researchers like Morton Christensen and Nick Chater theorize, language primarily adapted to the brain's existing architecture over time. It wasn't really the other way around, with our brains evolving solely to accommodate language.
Wow. That's a profound shift in thinking, isn't it? So it's less about some sudden invention and more about our brain being this incredible master tinkerer, taking its general purpose superpowers and unlocking something entirely new with them. Absolutely. Our highly developed frontal lobes, which saw really significant growth over the last 2 million years or so, they provided that crucial spark. They enhanced these domain general skills, creating the perfect sort of substrate for communication to evolve into the complex language we know today. It's really a testament to the brain's incredible adaptability, its capacity for repurposing things.
All right, okay, so our brains start off as these general-purpose supercomputers, basically capable of anything. But then, how do we get so incredibly specialized in our native language? And maybe more relatably, why is it such an uphill battle for adults like me trying to learn Spanish to pick up new speech sounds in a foreign language? I'm thinking about, the classic example, the R and L sounds for Japanese speakers learning English. Why is that so hard?
That's a fantastic observation, and it brings us right to a truly mind-bending concept: the perceptual magnet effect. It's a term really brought to prominence by cognitive scientist Patricia Kuhl.
Perceptual magnet. Okay.
What's fascinating, absolutely fascinating, is that newborn babies are actually innately capable of perceiving and distinguishing all phone contrasts.
Phone contrasts.
Yeah, those are the smallest units of sound that differentiate meaning in a language, like buh versus puh in bat and pat. So babies can hear these tiny differences across all human languages. We know this from these clever studies using habituation techniques.
Habituation?
Yeah.
How does that work with babies?
Well, researchers show that babies, even really young ones like 1 month old, will show surprise or renewed interest when they hear a new sound after they've gotten used to or habituated to an old one. It's basically their way of telling us, hey, I noticed that sound is different.
So infant brains are like Like universal translators,
Huh?
open to every possible sound distinction.
Exactly. They start with this incredible, wide-open capacity, but then something amazing and maybe, a little sad in a way happens. Through massive exposure to their native language, especially during that critical first year of life, their brains undergo significant neuroplasticity.
Ah, neuroplasticity, the brain rewiring itself.
Spot on. Neuroplasticity is the brain's amazing ability to physically change its structure and function based on experience. And in the case of language, the brain actively prunes, which means it weakens and removes neural connections that aren't involved in processing native speech sounds. And at the same time, it strengthens and solidifies those connections that are essential for the home language.
It's like use it or lose it, but for sound perception.
Precisely. This whole process creates what Kuhl calls prototypical categories for native phonemes. Imagine these categories acting like perceptual magnets.
Magnets.
Yeah, so for a Japanese speaker, for instance, sounds that an English speaker hears as clearly distinct R and L sounds often fall into a single broader phoneme category in their native language. Their brain forms one powerful perceptual magnet for that whole range of sounds. So when they later encounter English words like rice and lice, their brain, pretty much out of habit and because of this neural wiring, tends to distort what it hears. It pulls both sounds towards their existing single category, and that makes it incredibly difficult to actually hear and produce the distinction. It literally changes how they perceive those specific sounds in the world. It's not just about hearing, it's perception.
Whoa. That's incredibly powerful. So our own native language literally warps our perception of sounds. It's not just about what our ears pick up, but how our brain actively decides to interpret that input based on all that early linguistic experience.
I never thought of it quite like that.
And that's a fascinating trade-off, isn't it? We get really efficient in our own language, but we potentially lose sensitivity to sounds in others.
It truly is. It highlights how our early linguistic environment molds the very machinery of our perception. It makes us specialists in our own language, but often at the expense of that universal flexibility later in life. It's really the brain optimizing for its immediate surroundings.
Okay, so if language can actively rewire how we perceive sounds, what about something even bigger? Our actual thoughts. This makes me think of that famous, maybe slightly oversimplified idea about Eskimo snow words. The notion that if a culture have loads of words for snow, they must think about snow differently. Is there any truth to that sort of idea?
That brings up a really crucial point, and it's right at the heart of the linguistic relativity hypothesis. Now, this is a more nuanced and, frankly, more plausible version of the older, stronger Sapir-Whorf hypothesis.
Okay, linguistic relativity, how's that different?
Well, while critics, like the linguist Jeffrey Pohl, rightly point out that pretty much any language can express almost any concept. I mean, an English speaker can describe snow drifting along the ground even without a single special word for it, just like an Inuit speaker might have one.
Right.
The key isn't whether you can express something, it's whether your language obligatorily makes you pay attention to certain distinctions over and over again.
Oh, I see. So it's about what your language forces you to notice and categorize, like every single time you speak or think in it.
Exactly. If a language habitually or obligatorily makes certain distinctions, it can indeed induce further neuroplasticity. It can cause our brains to specialize in noticing those particular things more readily. Let's look at some fantastic examples. Studies have shown that Russian speakers, for instance, they have distinct, separate, basic words for light blue, голубой, and dark blue, ясный.
Unlike English, where blue is the basic term.
Right. And because their language requires them to make this distinction constantly, they are consistently faster at distinguishing between these shades compared to English speakers. Again, it's not that English speakers can't see the difference, of course they can, but their language doesn't make them notice it reflexively automatically.
So if I were to learn Russian fluently, would my actual perception of blue change? Or would I just get faster at categorizing it? That distinction feels kind of important.
That's a great question, and it touches on where the research gets really fascinating. It's probably not about a fundamental change in the raw visual input to your eyes. It's more about how your brain processes and categorizes that visual information. The faster reaction times we see in Russian speakers, they suggest a more automatic, almost pre-attentive distinction. That points towards changes in the neural pathways involved in color processing. Their brain has become more efficient, you could say, at flagging that specific light-dark blue difference.
Interesting.
And there's another really compelling example. It comes from the Kuuk-Thaayorre community in Australia. Their language uses absolute cardinal directions, north, south, east, west, for all spatial relations.
All of them. How does that work?
Well, you wouldn't say the cup is to your left. You'd actually say something like the cup is to the northwest of you. Always.
Wow. Constantly orienting yourself.
Exactly. And this linguistic practice means that Kuuk-Thaayorre speakers demonstrate truly remarkable spatial orientation skills compared to, say, English speakers. They almost always know exactly which direction they're facing, even indoors, without obvious cues. It's like a built-in compass honed by language. It's like a conceptual magnet effect, but for ideas or spatial awareness. Language guides our brain to constantly pay attention to different aspects of the world, making us perceive and think about them differently.
Okay, that's incredibly persuasive. Those examples are strong. But let me just play devil's advocate for a second here. Isn't it still possible that the culture dictates this and language just reflects it? You know, like a culture that lives with a lot of snow naturally develops more words for it because it's important. The language follows the culture, not the other way around.
That's a fair point, a really fair point, and it's a key part of the ongoing debate. Culture certainly influences language development, no doubt about it, but what's becoming increasingly clear from the research is that the relationship is likely bidirectional. It's a two-way street.
Ah,
There's growing evidence suggesting that language can independently change the brain's structure and function. For instance, there were studies where Mandarin speakers were taught completely made-up words for novel shades of green and blue. And researchers actually saw measurable structural changes in the visual areas of their brains in as little as 3 days.
3 days. Just from learning new words?
Just from learning and using those new words, these changes weren't just about thinking differently. It looked like the brain was literally building new connections or strengthening pathways related to those specific color distinctions.
Wow. So language isn't just reflecting our reality. It seems like it's actively shaping the very neural hardware that processes that reality.
That's incredible. Precisely. It suggests that the brain's inherent plasticity allows language to deepen pathways or forge new ones, as some researchers put it. It accentuates or maybe even subtly alters our innate biases in perception and cognition. So it's not just a passive reflection, it's an active shaper, constantly sculpting our minds. The two, language and cognition, language and brain structure, they're intertwined in this really profound way. And you could argue that language has radically transformed the human mind into what it is today. Oh, should you remember just one thing from this deep dive today? Let it be this. Language is far more than just sounds, symbols, or a simple tool for communication. It is a living, dynamic system that actively rewires your brain, shapes your perception of reality, and fundamentally influences the very way you think about and engage with the world. It is, in essence, a kind of technological transformation, one that builds on our existing brain architecture to create something truly unique to us as humans.
I absolutely love that takeaway. It's simple, yet so incredibly profound, isn't it? It really makes you think about every word you speak, every sound you hear, every thought you structure. It makes you think about it all in a completely new light, almost as if language is a constant sculptor of your own reality. Thanks for breaking down these complex, fascinating ideas for us. That was a really insightful deep dive. And if you're as fascinated by these incredible ideas as we are, and you want to dive even deeper into the research we've been discussing today, you can find links to the source materials from our course right there in the description below. Check them out.
Yeah, and we genuinely love to hear from you all. Which idea resonated with you the most? Or maybe, what unexpected ways do you think language has shaped your mind, your perception of the world? Please share your thoughts and insights in the comments section. And just to leave you with something to think about, the philosopher Ludwig Wittgenstein famously said, "The limits of my language mean the limits of my world." What do you think that means for your world?